Okay, I have a few examples from page 478, some of the word problems. This first one is about the value of a sailboat that decreases 10% per year, and the question wants you to find the value after 5 years or 10 years or something like that. So basically the first thing you want to do is fill in the formula here, and P, that's the amount you're starting with, the principal, so let's put 3,500. 1 plus, what do you think R stands for in this problem? Hope you said rate, 10%. So how do I put 10% when I put it in a formula? 0.10. Okay, now what's interesting about this is because we're doing decreasing, I have to put my R as a minus. All right. Find the value after 5 years. That's the time, 5 years. What does this N stand for? That's the number of times this interest is done per year, or well, in this case it is 1 for per year, but if I was taking the interest monthly, I would put a 12 here. If I was taking it biannually, I'd put a 2, exactly. So now it's basically all calculator. Use your calculator, plug all of this stuff in. Sometimes people like to plug this in separately and get 1 plus negative 0.10 as one value first, and then figure it out. Of course, that's going to be 90%, right? 1 minus 0.10. So then do your exponent, final value, and I think you'll be able to do the rest of the problems that are like that one, so good luck. Alright, so in this formula I have a population problem, so I'm going to use the doubling time formula. And when you look at this formula, the n sub 0 stands for the population you start with, the n stands for the population that you end with, t is the time to get the ending population, and d, what we're going to find out, is the doubling time for the population in this situation. Now, before I get started, I don't like all of these large numbers in the millions, so I'm going to abbreviate them a little bit. I'm going to call the first one 3.5 million. I'm going to call this one 5 million. And then the population they want me to find the time to get to, we'll call that 6.5 million. And that will just save some of the numbers that we're writing. So now I'm going to use this formula. So let's use it with the given information first, because we need to find the doubling time so that we'll be able to find how many years it takes to get to 6.5 million. So taking what I have, the starting population is 3.5 million. The ending population, 5 million, times 2. And how long did it take me to get to the 5 million? From 1980 to 1990, 10 years. And the doubling time I don't know. So, all right, so now that I have some more room here, let's solve this problem that we wrote up from the information. We can solve this by taking the log of both sides. So I'll take the log of 5. Oh, before I do that, I just thought about something. Let's simplify this a little bit. Let's divide both sides by 3.5. All right? So let me do that on my calculator here for a second. So 5 divided by 3.5 is 1.428, so 1.43. So I'm going to rewrite this as 1.43 equals 2 to the 10 over d. You got that? Can you see that? So now I can solve this by taking the log of both sides. So I do the log of 1.43 equals the log of 2 to the exponent 10 over d. Remember what I can do with the exponent? Move it out in front, right? So log of 1.43 equals 10 over d times log of 2. Let's solve this some more. Multiply both sides by d. d log 1.43 equals 10 times log 2. How can I get the d by itself? Right, divide by log 1.43, log 1.43. Now I can do that arithmetic here, and when I solve this, I get d equals 19.4 years. And that means the doubling time for this population is 19.4 years. In 19.4 years, this population would be double this size, so it would be 7 million. Now, I want to find out how many years is it going to take to get to 6.5 million. It'll be less than 19 years. How can I use the information I have to solve that? Well, again, I'm going to use this equation. So, what's the population that I'm starting with? 3.5. What's the population that I want to get to? 6.5. All right, and then I have times 2. And what do I have for exponents here? T and D. Do I know the doubling time? Yeah, I figured that out. 19.4. I want to find out the time to get to this population. Now again, you're going to solve that by using logs. First thing you want to do though is divide 3.5 here so that I have the 2 to the exponent by itself. So I have 2 to the t over 19.4 equals 6.5 over 3.5. At this point, I can take the log of both sides, just like I did here, and solve the whole problem. And I'm going to leave that to you. So you take the log of this side and the log of this side, and then move the exponent down, solve it for t. You try to figure this out. See if you can get the answer. T equals 17.4. And what that means is 17.4 years from when this population, and remember this was 1980, this was 1990, so if I add 17 years to 1980, I should get 1997 is when the population will be 6.5 million, okay? And remember we said it doubled in 19 years, so that came out to less than 19, so our arithmetic is probably right. You need to see if you can figure this out, though, to get t equals 17.4, so make sure you can use your calculator. All right. Okay, the last type of formula we're going to use in this section is the half-life formula. And again, n sub 0 stands for the initial amount of some substance. N is what we have after some amount of time. And we're doing half-life, so you notice a half here, and the T stands for the time, and the H stands for the half-life of the material we're talking about. In this case, radon gas, and the half-life of it is 3.8 days, and that means whatever amount of radon gas you have, that amount will be half that size in 3.8 days. Now, I want you to notice the doubling formula we used in the last problem was very similar to this. The only difference is doubling, we're using a 2, half-life, we're using a half. What do you think we'd use if I had a tripling formula? A 3 there, okay? And then T over doubling time for this one, T over half-life for this one. So the formulas are pretty similar and pretty easy to use. And again, once you get the numbers plugged in, you have to use logarithms to solve them. So let's see, let's make it a go on this one. So the half-life is 3.8 days, so that's going to be my H. How much of 100 milligrams of gas will be left in 7 days? So the time is 7 days, right? And the amount of stuff I'm starting with, 100 milligrams, that's the n sub 0. So let's put this, we're trying to figure out how much is left, so we don't know the n, but we know that we're starting with 100 milligrams. We're doing the half-life formula, and we know that the half-life is 3.8 days, and we know that we were talking 7 days, so in 7 days, how much stuff is going to be left? Now all I have to do is solve this formula, and in this particular formula, you really don't have to use logs to solve it because I can just plug all of this into my calculator. But on some of the other ones you're going to have, when you have different pieces of information missing, you will have to use logs to solve. If you're trying to find the T or the H, you will have to use logs to solve both parts of the problem. But they're not that hard. Just try using the formulas and plugging this stuff in. I think you'll be fine. Good luck.